This drawing illustrates the limited expansion model. And here we have, and you can find this illustration in many astronomy books describing the expansion of space based on the limited expansion model, meaning that galaxies are gravitationally bound. The expansion of space stops outside the boundaries of galaxies with some unexplained transition between the two. And these galaxies are carried by the expansion of space. Here we have, well, we'll call it, often it's called buttons or pennies, glued to a surface of balloon. And as the balloon expands, the gravitationally bound galaxies are carried by the expansion of space. In this figure, we go look at the present and we go back into the past. And then we get to the very early universe. And we can see at the beginning of the universe, we have a little bit of trouble trying to figure out how we get galaxy-sized structures. And they all got clumped up, so there's a little bit of chaos or unexplained relationships to find when you get to the very early universe. But ignoring that issue with that model for now, these arrows indicate the rate of expansion. And as we see, as time goes on, the rate of expansion becomes less and less because effective gravity is resisting this expansion of space. And then my proposed model, which is not this one here yet, right here, illustrates my geometric expansion model. And here we have the same sort of balloon, but now if you look back in time, we see that the galaxies are actually contracting. If we were to use the balloon analogy, we would have to draw the galaxies on the balloon, and if we would look at them in the past, they would be smaller and denser. And similarly, we have the same slowing of the expansion rate as there is expansion, because there's still this gravitational interaction or conformance to a kind of geometry. And there's also, this arrow here indicates the velocity along an unobserved dimension. It would be greater in the past and less in the present because expansion comes at a cost, not only for objects, for every object. Now, and one thing to help visualize this motion along an unobserved dimension, here we have the flatland universe example moving along an unobserved dimension. But this time here we can see a kind of cone representing a kind of structural relationship or interface between observable space and unobserved space. And here observable space is moving along an unobserved dimension with a certain kind of velocity. So this helps visualize the model being proposed.